Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss sequence and series. In the previous class, we have already discussed the concepts of exercise 9.1. In that exercise, we have discussed what is meant by a sequence, what is meant by terms of a sequence, how to denote the terms of a sequence, and a series, and what is meant by a series, and a summation notation, sigma notation. I hope you have understood the concepts of exercise 9.1. We have completed the sums in the exercise 9.1 as well. I hope you have learned well the sums in the exercise 9.1. Now come to the concepts of exercise 9.2. Are you ready to listen the class? Right. In this class, let us recall the previous knowledge. You have already learnt arithmetic progressions, geometric progressions in your earlier class. Haven't you, my dear children? Yes. So let us recall that previous knowledge. See, first point, arithmetic progression. This is also denoted by A dot P dot. Okay, my children, arithmetic progression. A sequence A1, comma A2, comma A3, comma and so on, AN, comma and so on is called arithmetic sequence or arithmetic progression. If an plus 1 is equal to an plus d, comma n belongs to capital letter N means natural numbers, where a1 is called the first term and the constant term d is called the common difference of the AP. Okay, my children, understood this point? You have already learnt in earlier class about arithmetic progression. So we define like this: arithmetic progression means the terms a1, a2, a3 and so on, an and so on. The relation between the terms is defined like this: an plus 1 is equal to an plus d, where n belongs to capital letter N, natural numbers, and a1 is first term of the arithmetic progression, and small letter d denotes the common difference of the arithmetic progression. Okay, my children. Let us consider an AP means arithmetic progression in its standard form with the first term A and common difference D, that is A comma A plus D comma A plus 2D comma and so on. This is called standard form of arithmetic progression. What is this form called? The standard form of arithmetic progression. Then nth term, this is also called general term of the AP, is an is equal to a plus an minus 1 into d. Okay, my children. This point also we have already learnt in earlier class. Nth term of an AP, general term of an AP, arithmetic progression. Okay, my children. Right. Understood these points? We have already learned. Just we are recalling, we are bringing that knowledge back into your mind. Okay, my children. Right. Come to the second point. Some properties of an arithmetic progressions. First point, if a constant is added, if a constant is added to each term of an arithmetic progression, the resultant sequence is also an arithmetic progression. Okay, my teacher, suppose this is an arithmetic progression. If some constant is added to each and every term of this arithmetic progression, then we get a new sequence. The resultant sequence is also an arithmetic progression. Okay, my children, understood this point? Right. Come to the second point. Similarly, if a constant is subtracted from each term of an arithmetic progression, the resulting sequence is also an arithmetic progression. Okay, my children. Suppose this is an arithmetic progression. If a number is subtracted from each and every term, if a constant term is subtracted from each and every term of this arithmetic progression, then we get a new sequence. The new sequence, the resulting sequence is also an arithmetic progression. Understood this point, my dear children? Right. See the third point. If each term of an AP is multiplied by a constant, then the resulting sequence is also an AP. Okay, my dear children, understood this point? If you multiply each term of an AP by a constant, then we get a new sequence. The new sequence, the resulting sequence is also an arithmetic progression. Okay, my dear children. Now come to the fourth point. If each term of an arithmetic progression is divided by a non-zero constant, then the resulting sequence is also an arithmetic progression. Understood this point, my dear children? If you divide each and every term of the arithmetic progression by a non-zero constant, then we get a new sequence. Then the resulting sequence is also an arithmetic progression. These are the properties of arithmetic progression. Okay, my children. Right. Come to the third point. Here we shall use the following notations for an arithmetic progression. For the upcoming exercise, means in the 9.2 exercise, we use these notations. Okay, my children. The entire exercise is based on arithmetic progressions. Okay, my children. Right. Here A denotes the first term of the arithmetic progression. L the last term of the arithmetic progression. D denotes the common difference of the arithmetic progression. N denotes the number of terms. Sn. Okay, medicinal. Sn. Here N is a subscript. Okay, medicinal. Don't write S after N. Don't write these two letters in the same line. S here subscript. Sn is equal to the sum to n terms of arithmetic progression. These are the notations we use in this exercise 9.2. Okay, my children, you have to remember these points. Let a, comma, a plus d, comma, a plus 2d, comma, and so on, a plus n minus 1 into d be an arithmetic progression. We know this is a standard form of arithmetic progression. Then L is equal to a plus n minus 1 into d. L means what does the letter L denotes? The last term. Okay, my children, the last term of the arithmetic progression is equal to a plus n minus 1 into d. Sn. What does Sn denotes here? The sum to n terms of arithmetic progression. That is equal to n by 2 of 2a plus n minus 1 into d. If you want to find the sum to n terms of arithmetic progression, we can use this formula or this formula. That is equal to n by 2 into a plus l. Understood these points, my children? Right. These are the points related to arithmetic progression. These are the concepts for the exercise 9.2. The concepts of exercise 9.2 were completed. Now let us start the sums in the exercise 9.2. Okay, my children? Right. Now come to the question number 1. First question in this exercise 9.2. Find the sum of odd integers from 1 to 2001. Understood this question, my dear children? We have to find the sum of odd integers from 1 to 2001. Okay, my dear children? So, right. Let us recall the previous knowledge of odd numbers. What is meant by odd integer? Yes, the number which is not divisible by 2. Okay, my children. So let us write the odd integers between 1 and 2001. Odd integers from 1 to 2001. 1, 3, 5, 7, 9, 11, and so on. Yes, so my children, these are the odd integers from 1 to 2001. Now we have to find the sum of all these numbers. Okay, my children, these are all form arithmetic progression. This sequence form an arithmetic progression. Yes or no, my children? Because second term minus first term, third term minus second term, common difference, same. Yes or no, my children? This sequence is an arithmetic progression with first term. What is the first term? A is equal to 1. Common difference. How do you find common difference? An plus 1 minus an. Okay, my children. Means second term minus first term, or third term minus second term. 3 minus 1. What you get? 2. That is a common difference of this arithmetic progression. We found here the first term of this arithmetic progression and the common difference of the arithmetic progression. But to find the sum to the numbers from 1 to 2000, the sum of the numbers from 1 to 2001, the sum of odd integers from 1 to 2001, we have to find how many terms are there in this sequence. Okay, my children. So this is the last term, nth term. Yes or no, my children? Last term or nth term of this sequence. Nth term or last term, that is equal to Tn. That is 2001. Yes or no, my children? This is the last term. Or you can write L also. So Tn, how do you denote? A plus n minus 1 into D is equal to 2001. This is the formula for nth term of arithmetic progression. Do you remember this formula, my children? Right. In this formula, we substitute A and D value because we have already found. So 1 plus n minus 1 into 2 is equal to 2001. Understood this step, my children? So from this equation, we solve the equation for finding the value of n. Okay, my children? So we transpose this 1 to RHS. So n minus 1 into 2 is equal to 2001 minus 1. Okay, my children? Understood this step? So n minus 1 into 2 is equal to 2000. 2001 minus 1. What do you get? 2000. Here n minus 1 is equal to 2000 by 2. We are transposing number 2 to RHS. Then it becomes by 2. Yes or no, my children? So 2 once 2000 times. This implies n minus 1 is equal to 1000. This implies n is equal to 1000 plus 1. If you are transposing, if you are moving minus 1 from LHS to RHS, it becomes plus 1. This implies n is equal to 1001. What does n denote? Number of terms of an AP. Previously we have discussed in the at the time of concepts. N denotes number of terms. So how many terms are there in this sequence? 1001 terms are there. Yes or no, my children? Right. Therefore, yes, n is equal to n by 2 into a plus l. You know, this is the sum of the terms, sum of the numbers in the arithmetic progression. Yes or no, my children? This implies yes, n means 1001. There are 1001 terms are there. Okay, my children? 1001 by 2 into what is a here? 1 plus 2001. Last term is 2001. Understood this point, my children? Understood this step? That is equal to 1001 by 2 into what will you get here? 2002. 2001 plus 1. What will you get? 2002. Yes or no, my children? Right. 2 1 times 2, 1001 times. Then what you get? Then multiply these two numbers. 1001 into 1001. 100. Multiply these two numbers. Then you get 10 lakhs 2001. Okay, my children. Understood? Right. Now come to the question number 3. Here I am not explaining question number 2. Question number 2 is the same as that of question number 1. Please try question number 2 yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Right. Now come to the question number 3. In an arithmetic progression, the first term is 2. The first term is 2, and the sum of the first 5 terms is 1/4 of the next 5 terms. Understood this point, my children? Show that 20th term is minus 112. We have to prove that 20th term of this arithmetic progression is minus 112. Okay, my children? Right. Now let us write given data. Here, if you observe, there are here first 5 terms and the next 5 terms. So, let us take 10 terms. The standard form of arithmetic progression with 10 terms. Okay, my children. Let the arithmetic progression with 10 terms in the standard form. A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D, A plus 7D, A plus 8D, A plus 9D. See there, my dear children, how many terms we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 terms, because here first 5 terms, next 5 terms. So total we have taken 10 terms in the arithmetic progression with the standard form. Where A is the first term, where A is the first term, and D is the common difference. Now come to the question. What is given here? The first term is 2. Yes or no, my children? Given the first term of the AP arithmetic progression is that is equal to A is equal to 2. And what is the given condition? The sum of the first 5 terms. Let us find the sum of the first terms. Given sum of the first 5 terms. What is the condition? The sum of the first 5 terms is equal to 1/4 of the 1/4 of the next 5 terms. Sum of the next 5 terms. That means A plus 1/4 of the 1/4 of the next 5 terms. Okay, my children. Next 5 terms. I wrote this given condition in the form of a sentence. Okay, my children, so understood this step, right? This implies sum of the first five terms. What are the sum of the first five terms? A plus D plus A plus 2D plus A plus 3D plus A plus 4D is equal to 1 by 4 of A plus 5D plus A plus 6D plus A plus 7D plus A plus 8D plus A plus 9D. 1/4 of the sum of the next five terms. Understood this step, my children? Right. This implies what will you get? 5A plus 10D is equal to 1 by 4 into 5A plus 35D. Okay, my children, by simplifying A terms, we get to 5A. By simplifying D terms, we get to 10D. Understood this 5A plus 10D, my children? That is equal to 1 by 4 into, here also in the square brackets, if we simplify A terms, we get 5A. And after simplifying the D terms, we get to 35D. Okay, my children? Understood this step? Right. Now in this step, let us substitute A is equal to 2. So 5 into 2 plus 10D is equal to 1 by 4 into 5 into 2 plus 35D. Because A is equal to 2. It is given in the question itself, the first term of this AP. That is why we substituted A is equal to 2 in this step. Then we got this step. Understood this step, my children? Right. By simplifying this, by solving this equation, we get the value of D. Okay, my children? Right. So 10 plus 10D is equal to 1 by 4 into 10 plus 35D. Okay, my children? Right. Now cross multiplication. Let us cross multiply. 40 plus 40D is equal to 10 plus 35D. Okay, my children, understood this step? Right. This implies 40D minus 35D is equal to 10 minus 40. I transposed this 35D to LHS and the 40 to RHS. Then we got this step. Okay, my children, understood this step? Right. This implies 5D, 40D minus 35D. What will get? 5D is equal to minus 30. Understood this step, my children? Right. So D is equal to minus 30 by 5. Okay, my children? 5, 6 times. So D is equal to minus 6. This is the common difference of the arithmetic progression. Then what is asked here? 20th term. Okay, my children? We know that nth term that is equal to an is equal to a plus n minus 1 into d. Yes or no, my children? In the arithmetic progression, nth term is equal to a plus n minus 1 into d. Now let us find 20th term. 20th term is equal to a20 in the place of n, write 20, and a is equal to 2. 2 plus n, that is 20 minus 1 into d. What is d here? 6. Because a is equal to 2, d is equal to minus 6. Understood this step, my children? Right. That is equal to 2 plus here what will get to 19 in this brackets into minus 6. Yes or no, my children? Understood this step? So 2, 6 19s. 114. Okay, my children, 19 are 114. So minus 112. This is the 20th term of AP, which is to be proved. Yes or no, my children? Hence proved. Understood, my children? Right. Now come to the question number 5. Here I am not explaining question number 4. Okay, my children, please try the question number 4 yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children. Right. Now come to the question number 5. In an arithmetic progression, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first PQ terms is 1 by 2 of PQ plus 1, where P is not equal to Q. Understood this question, my children? Right. Actually, in this arithmetic progression, we don't know what is the first term and what is the common difference. These two are very important for an arithmetic progression, but we don't know the two concepts. So let us assume that let us consider A be the first term, A be the first term, and D be the common difference. Common difference of an arithmetic progression. Let us assume that. Okay, my children, we don't know what is the first term and what is the common difference. Without knowing these two, we can't find any sum related to arithmetic progression. Okay, my children? Right. Now come to the question. What is given here? Pth term. We know nth term of an AP. We know that nth term of an AP, Tn, we can use Tn also to denote nth term. Okay, my children? Or An, nth term of an AP is equal to A plus n minus 1 into D. Then what is given here? Pth term. Given pth term of the AP is equal to 1 by q. As or no, my children, it is given itself in the question. Pth term of the AP is 1 by q. Okay, my children. This implies pth term means A plus P minus 1 into D is equal to 1 by q. Okay, my children. Understood here? Just we substituted in the place of P, in the place of N. Similarly, qth term of the AP is equal to 1 by P. It is also given in the question itself. Qth term of the AP is equal to 1 by P. This implies, how do you write in the notation form? Qth term means A plus Q minus 1 into D is equal to 1 by P. 1 by P. This is consider this is equation 2. Okay, my children. If you observe these two equations are linear equations in two variables A and D. These are unknown quantities. We have to find out what is A, what is the first term of this arithmetic progression, what is the common difference of this arithmetic progression, which were not given in the question. So we have to find them. Okay, my children. So let us solve. Second equation minus first equation. We can first equation minus the second equation. 1 minus 2. Okay, my children. Then what will get? here minus, here minus, here minus. Yes or no, my children? Then what will you get here? A plus A minus A gets cancelled. P minus 1 minus of Q minus 1 into D. Yes or no, my children? This term minus this term. Okay, my children. 1 by Q minus 1 by P. Understood this step, my children? Right. This implies, let us simplify, P minus Q into D is equal to 1 by Q. Let us simplify here. PQ is the LCM for these two denominators. Then what will get in the numerator? P minus Q. Yes or no, my children? Right. Here P minus Q gets cancelled. This implies D is equal to 1 by PQ. So we got here the common difference of the arithmetic progression. Understood this step, my children? Now we have to find the first term of this arithmetic progression by substituting this value D in the equation 1 or in the equation 2. Understood this point, my children? Right. Hello. Now let us substitute D is equal to 1 by Q. Substitute D is equal to 1 by PQ in the equation 1. Then we get, what will you get here, my children? A plus P minus 1 into D is equal to 1 by Q. This is the equation 1. Yes or no, my children? So, in this equation, we are substituting D is equal to 1 by Q. So, 1 by PQ is equal to 1 by Q. Okay, my children, understood this one? Right. This implies from this equation, we have to find the value of A. Okay, my children. So, A plus P minus 1 by PQ is equal to 1 by Q. Okay, my children, understood this one? So, A is equal to 1 by Q minus P minus 1 by PQ. Understood this step, my children? Right. This implies A is equal to, let us take LCM for these denominators. What do you get? PQ is the denominator. Then in the numerator, what you get? P minus P plus 1. Okay, my children, understood this numerator? Right. Plus P minus P gets cancelled. A is equal to 1 by PQ. So we got the first term of arithmetic progression. Okay, my children. Now let us find the sum of the first PQ terms. Okay, my children. Now sum of the first PQ terms. PQ terms of the arithmetic progression. It is denoted by SPQ. Yes or no, my children? We know that Sn is equal to n by 2 into A plus n minus 1 into D. Here we use this formula to find the sum of the first PQ terms. Okay, my children? So, sum of, in the place of n, we write PQ. Okay, my children? Is equal to, SPQ is equal to PQ by 2 into A 1 by PQ plus n minus 1 PQ minus 1. In the place of n, we write PQ. So, PQ minus 1 into 1 by PQ. D means 1 by PQ. Yes or no, my children? Because n is equal to PQ, A is equal to 1 by PQ, and D is equal to 1 by PQ. Okay, my children, we substituted these three values in this formula. We got this step. Understood this step, my children? Right. This implies PQ by 2. Here LCM is PQ. Yes or no, my children? PQ. What will you get? 1 plus PQ minus 1. Yes or no, my children? Sorry. 2a plus n by 2 into 2a plus. So 2. Okay, my children. Then we get here 2a. So 2 by PQ. Okay, my children. N by 2 into 2a plus 2a plus n minus 1 into d. In this formula. Okay, my children. Right. Then what will you get? PQ by here PQ gets cancelled. Okay, my children. Then what will you get in the numerator? PQ plus 1 by 2. Hence proved. Yes or no, my children? Hence proved. Understood, my children? Right. Here I am not explaining question number 6. Please try the question number 6 yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Will you try the question number 6 yourself? Right. Now come to the question number 7. Find the sum to n terms of the arithmetic progression whose kth term is 5k plus 1. Okay, my dear children, understood this question. In this arithmetic progression, we are not given the first term and common difference. Previously, I told you, any question related to arithmetic progression, if you solve the question related to arithmetic progression, we should know a value, that is the first term of the arithmetic progression, as well the common difference of the arithmetic progression. Without knowing which, we can't do any sum related to arithmetic progression. Okay, my children. In the previous questions, sequence were given, first terms are also given, the common difference also given. We have found nth term, but here kth term is given. Then we have to find the first term and the common difference. Okay, my children. Right. Given kth term of an arithmetic progression is tk. Okay, my children. 5k plus 1. This is a kth term. Notation of kth term. Kth term. Okay, my children. Or you can write ak also. Both denote the same. Okay, my children. Right. Now let us substitute k is equal to 1. Then we get first term. Let us substitute k is equal to 2. Then we get second term. Okay, my children. Put k is equal to 1, 2, 3, 4 and so on in the above equation. In the above equation, then what will you get? Put k is equal to 1. This implies what will you get here? T1 is equal to 5 into 1 plus 1. Okay, my children, in this equation we are substituting first k is equal to 1, then we get first term of the AP. Okay, my children, understood this logic? Right. 5 plus 1, what will you get here? 6. This is the first term of AP. Put k is equal to 2. K is equal to 2. Then second term. So 5 into 2 plus 1. Then what will you get here? 5 to 10 plus 1, 11. Understood this step, my children? Put k is equal to 3. This implies T3, third term. 5 into 3 plus 1. What will you get here? 16. Understood this third term, my children? Put k is equal to 4. This implies fourth term of this arithmetic progression. 5 into 4 plus 1. What will you get? 21. And so on. And so on. Okay, my children? And so on. So therefore, the first term of the arithmetic progression. What are the terms? 6, 11, 16, 21 and so on. So we got here, we wrote arithmetic progression. Then what is the first term? A, 6. A is equal to first term. That is equal to 6. Now common difference. Common difference. D is equal to, how do you find second term minus first term, or third term minus second term? Okay, my children. So T2 minus T1. Second term minus first term. What is second term here? 11 minus 6. Okay, my children, understood this one? So common difference is 5. First term A is equal to 6 and common difference is 5. We have found the values of A and D. Then we can find any question related to arithmetic progression. Then what is the question here? We have to find the sum to n terms of this arithmetic progression. Then let us write sum to n terms of the AP. Sn is equal to n by 2 into 2a plus n minus 1 into, okay my children, do you remember this formula? Right, this is equal to n by 2, 2 into what is a here? 6. 2 into 6 plus n minus 1 into 5. Understood this step, my children? Right, that is equal to n by 2 into, what we will get here? In the brackets, 2 6 are 12 plus multiply using the distributive property, 5n minus 5. Understood these three terms, my children, in the square brackets? Right, that is equal to n by 2. What will get? 12 minus 5, 7. 5n plus 7. 5n plus 7. This is the sum to n terms of the arithmetic progression. Understood, my children? Right.